Hi and welcome to Vulkan from Zero to Hero.
In this section, we are going to draw our first triangle. In this video, we are going to use command buffer in order to clear a screen. Welcome back. So far, we've successfully created the primary Vulkan objects in order to fill swap chains buffer. Now it's time to use command buffer and other classes to clear a screen. In this video, we are going to write some codes in scene class in order to clear a screen with blue color. Let's go to the scene header and include necessary headers. Here we need render pass and command pool headers. In the private scope of this class, declare the following function. We need a function namely build command buffers in order to build our command buffers. Also, we need to add some private members here. A viewport object, a viewport Caesar object, render pass object, command pool object, which will be used for creating command buffers, and finally a fence in order to synchronize CPU and GPU. Now go to the scene.cpp. First of all, set the initial value for fence object, which is 0. Then go to the load function. First, store graphics device in a local pointer called _G device. Do the same for present window, width and height of window. We should initialize viewports elements, set 0 for X and Y offset, and set height and width of window to viewports size. Make sure to set the minimum and maximum depth for this viewport. Okay, now it's time to initialize elements of viewport Caesar. We should set offset and extent of viewport Caesar. Define attachments, buffers for our render pass. Each attachment of render path should contain swap chain image view buffer as color and depth buffer as depth. Now simply call load function of render path and pass the following parameters, and this function will do the rest. As always, check the return result of the function and print any necessary message to the output in case we run into any unexpected situation. Create a fence using VK_createFence function. Make sure to create fence createInfo object because the function needs this createInfo in order to create fence object. You need two primary command buffers. Two comes from number of our swap chain image views. Because we wanted to use double buffering, so the minimum size of our command buffers is 2 for sure. Call load function of command pool with the following parameters. Now it's time to call build command buffers function. This function is responsible to record our command buffers with our commands. Begin the primary command buffer, and between begin primary function and end function of command buffer, we should record our commands. Define clear color as a constant blue color and then just call begin and end functions of render pass. We don't need to write any code between these two functions for the moment because we just need to clear our swap chain image buffers. Now in the render function, first we should call prepare function of device. This function was not declared before, so we have to add it to device class. Let's go to the device manager header and add this function to device class. Then go to the device manager.cpp and implement it same as here. First, we need to wait for VK acquire next image KHR. The VK acquire next image KHR acquires a presentable image from swap chain that an application can use and sets image index of swap chain. The presentation engine may not have finished reading from the image at the time it is acquired. So the application must use either semaphore or fence or both to ensure that the image layout and contents are not modified until the presentation engine reading is completed. Okay, go back to the scene.cpp and right after calling prepare function, get the current swap chain index and set wait destination stage mask. We should get current command buffer based on index of swap chain image and then reset our fence. We need two other functions for device class. Let's call them submit and present. One is responsible for submitting command buffer to the graphics queue and the other for presenting the queue to the device. Go to the device manager.cpp and let's implement these functions. In submit function, we need to create submit info and then call vkqsubmit. The structure of vk submit info needs an information of command buffers, wait destination stage mask, and information of semaphores. You can wait for this queue to be idle and then return from this function. It's up to you really. In present function, we should call vkqpresentKHR in order to present the image. The vkqpresentKHR needs an object with the type of vkpresentinfoKHR. This structure contains some information about the number of semaphores, swap chain, and also the current index of swap chain's image. Go back to the scene.cpp and call submit function after resetting fence. All we need to do is wait for fence to be signaled in order to present our final image. Let's double check our codes again. In load function of command pool, we should store count of command buffers at the first line of function. And in submit function of device, I think we've missed something. We should set information of signal semaphores. Nice. Now I think we can run our project. We expect the application to present a window with blue color. And here we go. In the next video, we are going to create pipeline.